Good morning. This is your stats sensei, Mr. Spensei, and this is the semester review part three. And this will be problems 54 through 75. So, two pain relief medicines are tested on random samples of post operative patients at the 5% significance level. So, they're telling us our alpha level is 0.05. Give me just a moment. I need to slip my glasses on um, as to whether or not the mean duration of relief are different. So we're looking to see if there's a difference. The data are given below. So we have sample size, we have mean relief, and we have standard deviation for both of them. And we have two different groups. Because we have two different groups, this is going to make this a two sample t, which will have this formula t equals x1 minus x2, s1 squared, etc. Our null hypothesis is the mean of brand A equals the mean of brand B, and the alternative, since they said they were different, is not equal. And that's going to be very key that we have the not equal again. So we're going to just go over and drop into stat test. Stat test, we have two groups, and everything is coming from the sample. So this makes this a two-sample t-test. And x1 is 131. Standard deviation was 12, and the sample size was 20. For group two, we have 140 as our mean, and standard deviation of 15, and our sample size is also 15. Now, be careful. We want to make sure we have not equal because we have the word different. When we press enter a couple times, oh, we never pool. And I end up getting a p-value of 0.067. All right. So my p-value is 0.067. My alpha level was 0.05. This is greater, so we're going to fail to reject. So p is greater than 0.05, so fail to reject. So our answer choice number 54 is D. Number 55, a real estate agent claims that the mean sales price for homes in a city is 258,000. A building contractor runs a check on a sample of 10 recent sales and notes the average sales was 245 with a standard deviation of 38,000. What is the test statistic in performing a hypothesis? Well, first off, the claim is 258,000 and they tell us we're looking for a difference. All right. So T equals X bar minus mu S divided by the square root of N. Well, mu in this case is 258,000. X bar is what came from the sample is 245,000. The sample mean of 38,000. And that tells me, because we're using the sample mean, that tells me I'm using a t-test. And we have a sample size of 10. So I need to plug in. So I'm plugging in 258,000 here, 245,000 there, 38,000 here. So this is going to look like 245,000 minus 258,000 over 38,000 divided by the square root of 10. So the one that has that is letter D. So our answer choice to 55 is D. Number 56, a researcher believes that a new diet should improve the weight gain in laboratory mice. If the average gain for 12 mice on a new diet is 5.3 and with a standard deviation of 0.5, while 15, and that was a sample size of 12, so N is 12. That's the new. And the control mice had an average gain of 5 ounces and the standard deviation of 0.4. Excuse me, I should slide that up. And we have a sample size of 15 for the control. So here we have two different groups. We have a new group and a control group. So this is going to be a two sample T. So that's where I'm going to need to go to on the calculator. So stat test, two sample T test, 5.3, 0.5, and a sample size of 12. The next one had a sample mean of 5, a sample standard deviation of 0.4 and a sample size of 15. But what were they looking for? This new should improve. That means my null is going to be equal, but my alternative will be that it's greater than. So I need to make sure I have the greater than symbol highlighted. And when I do that, I end up getting a p-value of 0.0529. All right, so 0.0529, well, it doesn't fall here because it's greater than 0.025. It's greater than 0.05, but it falls between 0.05 and 0.1. So my answer choice to 56 is D. All right, moving right along. Number 57. Men and women are surveyed as to the ideal number of children a family have. For 500 men, the average was 2.95 with a standard deviation of this. And for 450 women, the mean was 3.05. And they want us to establish a 90% confidence interval. All right. So in this case, this was not the correct formula. This should be X bar for men minus X bar for women plus or minus T star S1 squared over N1 plus S2 squared over N2. All right. So we have a sample mean of 2.95 for the men. And we have a sample standard deviation of 1.65 for the women. We'll leave out T star for a moment. We'll have to calculate that. And then we're going to have to go to sample standard deviation of 1.65 squared over 500 plus for the women, it was 1.8 squared over 450. All right. Now, this right here is kind of interesting. So we have 2.95. Oh, excuse me. This should have been 3.05 for the women. So 2.95 tells me this is negative 0.1. Well, that's what all of them have. All right, so all of them have negative 0.1. So that takes care of that part. So let's go ahead and run our test. Well, we have two groups. So, and this is a t interval because we're using the information from the sample. And for the men, we have a sample mean of 2.95 with a sample standard deviation of 1.65. And our sample size happened to be 500. For the women, we had a mean of 3.05, a standard deviation of 1.8, and a sample size of 450. And we want to create a 90% confidence level, 0.90. All right, the reason we did that is we needed our degrees of freedom. So our degrees of freedom here is 229.24. And I just read that off the calculator. All right. So I read that off the calculator. And so now I need to go back and go second bars, inverse T, 1.1 minus 0.90 divided by 2, with the degrees of freedom are 229.24. And I end up getting a T star value of about 1.65. All right. So the one that's closest to 1.65 is this. There's my 1.65. That's pretty close to it. And Everything else matches up exactly with the way I wrote it. Okay, so that's the answer to 57. Number 58, first year high school students were randomly put into either traditional math classes or math classes taught with a new innovative approach in standard algebra. 230 traditionally students scored 76.5 with a standard deviation of 7.4. So this is what we've written here. The 230, there's their mean, there's their sample standard deviation. And for with the new method, it raised up to 78.8 with a standard deviation of 5.6 and the sample size was 185. So is there evidence? So we're looking, as soon as I say, is there evidence, that means we're running some sort of hypothesis test. In this particular case, because we have two samples and we're using the sample standard deviation, this is a two sample T. So stat test, two sample T test, 76.5, oops, 7.4, 230, 78.8, 5.6, 185. And they told us they wanted us to use a not equal, so we need to make sure that we're using a not equal. We never pool. Calculate. Actually, I didn't even have to calculate. I just needed to plug in. So I should have gone back and plugged this in. So sorry about that. So this should be T equals 76.5 minus the 78.8 over 7.4 squared over 230 plus 78.8 squared over 185. All right, so that will take care of, so then I need to talk about the answer. Well, the answer choice to number 58, the one that looks like that, is A. Number 59, a quality inspector plans a test to test sample of 40 bottles of soft drinks labeled as 20 ounces. We're expecting a mean of 20 ounces because basically our null is the mean is 20. If she finds the mean content to be less than 19.8, she'll have the bottling company stop. So we're worried about less. HA mean is less than 20 ounces. If it's known the machine operates with a standard deviation of 0.75, so because they tell us that it operates with this is going to be a Z. All right. So this is going to be a stat test, Z test. What's the probability that the inspector will mistakenly stop a machine that's delivering a mean of at least 20 ounces? So we're trying to find this area here. All right. Because we stop the machine if we're less than 19.8. There's our mean if we get an X bar less than that. So we're going to go and run a stat test, Z test. Our mean is 20. Our standard deviation, they said that was known, was 0.75. That's where I got that from right there. We're going to stop it if we get a sample mean of 19.8. And we're going to test 40 bottles. And we're worried about it being less than. When I do that, I end up getting 0.0458. The probability of that happening by random chance alone is letter B, or 0.0458. All right, so moving on to number 60. Trying to move on to number 60. Kind of blurred here. Let's see if I can autofocus that a little bit. That's a little better. A congressional representative serving on the Joint Committee on Taxation states that the average yearly charitable contributions for taxpayers is below 50. So this is their claim. A lobbyist for a national church organization believes the real figure is lower, so less than. Um, and comes up with a mean of 1,092 and a standard deviation of 308. Where's the p-value? So this is coming from the sample. So we're working with a x bar minus mu s divided by the square root of n, except all we have to do is go to the calculator and run this. Because it's using the sample standard deviation, this makes it a t-test. And our mean, they said, was 1250. Our sample standard deviation is 1,092. Our sample, that's our sample mean. Our sample standard deviation is 308. And our sample size is 12. We said less than. And I end up getting a p-value of 0.0515. So 0.0515 falls between 0.05 and 0.1 because it's greater than 0.0. This 0.0515 is greater than 0.05. We have to be greater than that, but we're definitely less than this. So our answer choice is 60. It happens to be letter D. 61. A fitness instructor center advertises the average pulse rate of its members is 68.4. A high school AP Stats suspects this is a made-up number. Now, I didn't say that it was greater than or less than, but we run a hypothesis test on a simple random sample of 48, and we calculate a mean of 771, and our standard deviation from the samples is 10.3. Well, once again, because we're using the sample standard deviation, this means this is a one sample t-test. So, stat test, stat test t-test. The mean is claimed to be 68.4. The standard deviation, the sample mean was 71. The sample standard deviation is 10.3, and we had 48, and we didn't know the direction. They didn't say greater than or less than. They said it was just made up, so they're just not saying which direction. We ended up getting a p-value of 0.08. Well, 0.08 is greater than 0.05, but it's also less than 0.1. So our answer choice for letter D for 61 is also D because 0.08 falls within that interval. All right, going back to regression, looking at number 62. Before Challenger went off at 31 degrees Fahrenheit, each of the 23 earlier launches experienced from 0 to 3 O-ring failures. There was some speculation that the number of O-ring failures was related to the temperature at liftoff. A computer printout performed too late is shown below. Is there evidence of a relationship? Well, first off, this is the most important word, is constant. That tells me the y-intercept. So we need to find the slope row, which is right here. And our p-value is 0.0052. That's a small p-value. So where does that p-value lie? Well, we have some very small choices down here. Well, 0.0052 is less than 0.01. All right, so we're significant at that. But 0.0052 is greater than 0.001. All right, because 5 is greater than 1. So we're significant at 0.01, but not here. We would reject here, but we'd fail to reject there. So our answer choice to 62 is D. All right, moving on to 63. An automotive insurance company is interested in the association between SUVs and odometer reading for their clients. Data from 20 randomly selected clients generates the following computer output. Which of the following give a 96% confidence interval for the slope of the regression line? Slope plus or minus t star times standard error of the slope. Well, there's my y-intercept row because the word constant, so my slope row begins here. So that means my slope is 156.75.2. So that right away gets rid of those first three answer choices. So we'll go ahead and write that down. 1,056.75 0.2. We'll come back to T star in a moment. And our standard error of our slope is 1678. And they did something tricky here, but this is 1678. So we really know our answer. We know that this is the 1678, so it can't be this one. But we need to figure out how to get T star. Please note, it's not the T statistic. That's the test statistic. We need T star. So my degrees of freedom is 18, and we wanted to do a 96%. So here we go. Second bars, inverse T, 1 minus 0.96. Degrees of freedom was 18. And sure enough, we get the 2.214, at least we get that within rounding. So our letter answer choice is E for that problem. All right. Okay, below is a computer output for regression analysis starting salary in the thousands and college GPA. So we know we're looking at one of these is going to be Y and one of these are going to be X. What's the equation for the regression line? Well, my keyword is constant. So that means this is my slope row, which means GPA is my X, which means this is my X for GPA. That means salary, starting salary is Y. Okay, so we know it's going to be start off with salary, so we can get rid of A and we can get rid of C. My slope happens to be 11.8. So apparently, so if my slope is 11.8, and my y-intercept is 0.734. So I need a negative 0.734 times 11.82 times the slope. Well, the one that starts off with the correct y-intercept, there's my y-intercept, and there's my slope. The one that has those is B. So the answer choice to number 64 is B. All right, moving on to number 65. To study the relationship between calories and fat, slices of 14 randomly selected major brands are chemically analyzed. The computer output is as follows. What is a 90% confidence interval? Well, once again, constant, there's my constant row, that's my y-intercept. So my slope row is calories. So my slope happens to be right here at 0.0359 plus or minus. We'll come back to T star in just a moment. And my standard error is 0.0049. Now remember, for regression, degrees of freedom is n minus 2, and our sample size was 14. So 14 minus 2, our degrees of freedom are 12. So we need to do a 90%. So second vars, inverse T, oops, second vars, inverse T, 1 minus 0.90 divided by 2, degrees of freedom is 12. And we get 1.782. So 0.0359 plus 0.0782 times the 0.00490. So our answer choice for 65 is B. All right. Number 66. Can dress size be predicted from a woman's height? In a random sample of 20 female college students, dress size versus height gives the following results. What's the correct interpretation of 0.3736? Well, there's my y-intercept row. This is my slope row. So this is my slope. So when I write slope, I usually put it over 1. So 0.3736 slope over 1. Well, this tells me my height is X. So height is here and dress size is up here because that's what we said we were measuring, dress size versus height. and the height's in centimeters. All right. So for every 1 centimeter increase in height, nope. For every 1 centimeter increase in height, 1 centimeter increase in height, there's a increase because it's positive 0.3736 in dress size. All right. So as this goes up by 1 centimeter, as height goes up by 1 centimeter, the dress size increases by 0.3736. And I need to fix something real quickly. Oops, that did not fix it. There we go. And have an error on my key. There we go. Fixed. All right. So moving on to number 67. The computer output below shows the results of a linear regression analysis for predicting the concentration of zinc in parts per million from the concentration of lead in parts per million found in fish from a certain river. All right, so constant's my y-intercept. There's my slope. That means lead happens to be my x. So lead is my x, and zinc must be my y. Which of the following is a correct interpretation of the 19? Oh, well, that's my slope. Well, I'll write slope as a fraction. So 19 over 1. We know lead is the x, so it goes in the denominator, and zinc is in the numerator. On average, there's a 19 part per million in concentration of zinc for every increase in lead. So as lead goes up, zinc goes up, right? So as lead goes up, zinc goes up. So our answer choice to 67 is B. Number 68. A student has access to rainfall and sunshine data for a particular location over a period of 60 years. She randomly selects a sample of 25 months from the 730 months available and noted for each month in the sample the total rainfall and the total sunshine in hours. She then performed a regression analysis. Part of the computer output is shown below. All right. So which of the following is closest to the correlation? Well, remember, correlation is the sine of the slope, which is negative, and the square root of r squared. We don't use r squared adjusted. So this is going to be our sine of our slope is negative, and we're going to have to take the square root of 0.221. So we know our answer is negative, so that gets rid of those two. So 0.221. And all I did was raise it to the half power, and I get negative 470. The answer to 68 is A. Moving along. 69. Scientists have long believed that linear regression could be used to predict the brain weight of non-human mammals from the body weight. In one study, body weight in kilograms and brain weight in grams of 22 non-human mammals, so N equals 22, was measured. A linear regression analysis was performed, yielding the output below. Okay. Assuming all conditions for inference are met, which of the following expressions represents a 95% confidence interval for the slope of the least squares regression line? So our y-intercept, that's our constant row. This is my slope row. So here, this must be my slope. So 1.096 plus or minus. We'll come back to t star in a moment. We need our standard error of our slope is 0.1308. All right, so to do t star, we're going to need our degrees of freedom. And for regression, it's n minus 2. So 22 minus 2 is 20. So here we go. Second bars, inverse t, 1 minus 0.95 divided by 2. Degrees of freedom happen to be 20. So we're looking for a t star value of 2.086. They all have that. And so 1.096 plus or minus 2.086 times 0.1308. So the answer to choice of 69 is A. 70. A sociologist recorded the number of contacts entered in a cell phone and the number of texts sent in a week for 20 cell phone users. The resulting data were used to conduct a hypothesis to test and investigate whether there is a linear relationship. All right, so for our class, we've just said beta 1 equals 0. There is no linear relationship, and beta 1 does not equal 0. Because not equaling 0 would indicate that there is a relationship. So we need to make sure that we're using the capital letters. This would be for the sample. We don't want to use that. And we need a not equal. So our answer choice for number 70 is letter E. All right, 71. A state political analyst wanted to see whether there is an association between region where a person lives and whether the person is in favor of increasing the state gas tax. A random sample of 270 residents was selected, and the table below shows results. Which of the following is closest to the p-value of the appropriate test? And we said, hey, we're looking for association, so we're doing a chi-squared test of independence. Chi-squared test of independence. And I'm going to have to enter the matrix. Well, I've snuck ahead on this one, and I went second matrix. And notice this part right here is what makes my matrix. And I have 1, 2 rows and 1, 2, 3 columns. So this is a 2 by 3 matrix. So edit, 2, enter, 3, enter. And then I need to go ahead and enter my observed values, which is 38 and 27, 42 and 62, 51 and 50. Stat test, I'll go ahead and run the test, chi-squared test. And I end up getting a p-value of 0.0644, which makes my answer choice A. All right. Okay, 72. The National Society of Acupuncture asked a random sample of 450 adults their opinion about acupuncture being a reasonable form of medicine or not. The table below shows the responses. Assuming that all conditions for inference have been met, which of the following represents the correct chi-square test statistic? Hold on for just a moment. I'm getting a message that my computer is running out of battery. Hopefully it's not. It'd be bad if it is. Well, if it is, it runs out. So we're looking for an association. So that means I need to enter the data. In this case, I also have 2 rows and 3 columns. So this is a 2 by 3. And we need to calculate our degrees of freedom, which is going to be 2 minus 1 times 3 minus 1. So because it's rows minus 1 times columns minus 1. 2 minus 1 is 1. 3 minus 1 is 2. So degrees of freedom are 2. So that gets rid of A. That gets rid of C. And that gets rid of E. So I need to go into the matrix and go second matrix, edit, and I need to enter a 2 by 3. And we have 100. We have 80. We have 60. We have 60. We have 70. And we have 80. Once I've done that, I can go stat test, run a chi-square test. All right, so I have a p-value, but now I need to re-enter the matrix, second matrix, edit, and drop down. And there are my expected values. Please remember, for a chi-squared, it's observed minus expected squared over expected. So my first one should be 100, and I got an expected value of 85.33. So 100 minus 85.33 over 85.33. So the one that's over the expected is D. Because when I look at part E, they have observed minus expected over observed. And remember, it's observed minus expected over expected. So the answer choice to 72 is D. I'm really concerned I'm going to run out of power here. All right. 73, the super long problem. A random sample of 300 US cell phone users were asked their age and their question: do you regularly use your cell phone to text while eating dinner? The number of responses yes was tabulated for young adults and elderly adults. The results are summarized in the table. Which of the following um, would be appropriate hypothesis to investigate whether the survey provides convincing statistical evidence that there is an association? So this tells me we're running a chi-squared test of independence, and they want to see if there's association. So remember, chi-squared, the null is it is independent, so no association. The alternative is it is not independent, so there is an association. So this is what we'll be looking for. And remember, we're always talking about the population instead of the sample. So the first one talks about the sample, so it can't be A. The next one talks about differences, and we're not looking for differences. We're looking for association or independence. Part question C also talks about sample, so it can't be the sample. The next one says there is an association. Well, we're not supposed to be an association. We're supposed to be not an association for the null. So that's the wrong null. So we must be down to E. Well, E says there is no association, which means it's independent. So that's good. And the alternative says there is an association, which is not independent. And that is our answer. Because remember, for a chi-square test of independence or association, the null is it is independent, which means it's not associated. The alternative is it's not independent, which means it is associated. So 73 happens to be E. All right. Last page. Number 74, and this happens to be a reprint. So horseshoe crabs on a beach can be overturned by approaching waves. These stranded crabs may right themselves by turning over. During a period of many days on an Atlantic Ocean beach, investigators categorized a random sample of crabs as either stranded or not stranded, and additionally noted their age category, young, intermediate, adult. The researchers wanted to investigate whether there is convincing evidence of an association, so whether or not they're independent between becoming stranded and age. All right. If becoming stranded and age are independent in these creatures, which of the following is closest to the expected number? So if they are independent, what is the closest number? Well, remember, we want row total times column total. All right, row total times column total. I'm still getting messages. My computer is running low, and that really makes no sense. It really is disturbing. I'm checking one last time. All right. So So we wanted young and stranded. So yes for stranded, this for young. So to do this, it's row total times column total divided by total total. Row total is 218, column total is 194, and our total is 805. So when I multiply those out and I go 194 times 218 and divided by 805, I end up getting 52.53. My closest answer is B. So the answer to 74 is B. And the last question for the review, number 75. Measuring the height of a tree is usually more difficult than measuring the diameter of the tree. Therefore, many researchers use regression models to predict the height of a tree from its diameter, measuring at 4 feet 6 inches from the ground. The following computer output shows the results of a linear regression based on the heights in feet and the diameters in inches recorded from 31 felled trees. So my degrees of freedom in this case would be based on 31 minus 2. Degrees of freedom in this case would be 29 because our sample size was 31. This is the intercept row. This is my slope row. Which of the following is a 95% confidence interval for the slope of the population? Well, remember, slope plus or minus t star times standard error. So 1.054 plus or minus, we'll come back to t star in a moment. Our standard error they give us is 0.322. We need to calculate our t star, so second bar is inverse t. 1 minus 0.95 divided by 2 degrees of freedom is 29. And I end up getting a value of 2.0452. All right, if you notice here, we can't just plug this into the calculator, so we're going to have to plug and chug this. I have to separate this into two equations. So it's going to be 1.054 minus 2.0452 times 0.322. That'll be the lower bound. The upper bound will be 1.054 plus 2.0452 times 0.322. So when I go to solve that, I go 1.054 minus the 2.045 times 0.322. I end up getting a lower bound of about 0.3955. So my lower bound 0.3955, that's my lower. My upper bound is going to be 1.054 plus 2.0452 times 0.322, and I get an upper bound of 1.71. And the answer choice that was closest to that is B. So the answer choice to 75 is letter B. And that concludes things. I hope you'll watch this a couple times and familiarize yourself with the review so that your final goes very well. Thanks for watching and good luck on your final.